Uh, welcome, 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 welcome. Just want to do a physical science catch up, and yeah. No, really, many people they've been doing maths. Today is the physical science class, and we want to clarify some few things. Relative to the forces, relative to what we have learned. Yeah. Today people will see my face. I don't have a choice. Yeah? I don't have a choice. People will see my face today. I don't have a choice. Thank you very much for joining, guys. Thank you. Ne? So basically, I tried to emphasize just a few things which I feel like they're important for this example. Ne? Yes, Mr. Dion. Hey, thanks for your consistency. Today we are doing physical sciences. The catch up on physical sciences. Yeah. Like we've been doing maths. We've been working on the maths part. But today I feel like we should touch. Long time, one delay. Thank you, my friend. Today people they are able to see my face. I hope you can see how ugly I am. Yeah. In Newton's laws bafethu. Mara anganilahli siqala grade 11 then siya nayo siyisa ngalo grade 12 yabo. Sesiyayidonsa manje siyisa kuma momentum. Momentum and impulse. Young Frostan. Yes, thank you very much for the follow. Thank you very much. Today we are going to emphasize on Newton's laws, ne? So the first thing that you have to do, if you didn't understand maybe like very well, maybe like if you missed some of the lessons about the Newton's laws, I will just try and to be slow, ne? I will try to be slow. The eyebrow. The eyebrow. Rather the eyebrow. What's on not better. What's on? Now we can see where we have two objects in this system, right? They are connected with this string, ne? And the most important part of this exercise, ne? That's why I just took the most important parts, like the parts that I feel like they are important for this exercise, like this constant velocity. This is one system moving to the right with the constant velocity. And with this word, there are some things which we have to consider, guys. Because like things like constant velocity, we have to know how all the forces are balanced, right? When the constant velocity statement is a cheat. Yeah, it's not a cheat code. It's a what I can tell you, like it's just a hint on like it's like it is letting you to know or like no, all the forces are balanced and the acceleration is 0. So in simple terms, when the object is moving at the constant velocity, we have to know that that object, its acceleration is 0. It's like flowing on space, like the galaxies on space. Obviously they were just moving at the constant velocity unless a non-zero force acts on them. You see, it's like, let's talk about an acceleration where it's 0. A is going to be equals to 0 meters per second squared, right? Obviously that's when we can start by talking about the rest position. If maybe it doesn't move, you can leave your phone in the table. You can leave something. You can leave a car on the street, unless you come and drive it, guys. But if no one comes and interfere with this car, it will remain there. Because of why? The acceleration is 0, the velocity is 0. So obviously, who can tell me? Let's remind each other, guys. Ne? Under which condition is acceleration zero? This condition, when a system is moving at the constant velocity, or when the object is stationary, guys. Ne? This is when the object is stationary. And in this system, since we are told that the tow truck and the car, they are moving at the constant velocity, that's when we can get our acceleration to be zero. Thank you if you are helped, Mr. Dion. So now, let's see. We are just going to analyze these things. Be specific, Maloe, do it. Be specific on your lost path so that we can bring you back. We can come you back. So now, okay, I will just make several examples before we go to this question. Ne? Let's just say we have a construction site, maybe, or maybe we can. Okay, let me draw something like a picture. Okay, maybe I have a lovely picture here. Maybe the picture of a mother, okay, of the mother and a daughter or a son, ne? Yeah. Then obviously we have something like this. This picture, it is held by, you can see it is held yes, it is held, this picture, as you can see, it is held by T1 and T2, right? And T1 and T2, this one, it's 11 and 12, guys, ne? 11 and 12. I suggest if you're in grade 11, you can watch this. If you're in grade 12, you can also watch this. So this picture, it is held by this T1. Obviously, what do we know about the third law? Who can tell me? Can I please have third law? Third law. Because tension, it is acting in both directions. Obviously, we get this tension to be pulling this picture to that side, but we get the picture pulling this, whatever, it pulls this hole to this other side. So this force is going to be equal to that force, but they are not cancelling each other, guys. Yes, object exerts the same force in different direction, but without cancelling each other. Just like here, the tension is going to be the same because the car, it pulls this car, this total, it pulls the car with a certainty, and obviously the car, it pulls the tow truck with the very same amount of tension in different directions, but both of these forces, they are not cancelling each other. Am I clear on this one? Am I clear? Can I get a thumbs up? Am I clear? Because you can see, if the tow truck, it goes in that direction, it will pull the car. And as it pulls the car will try and resist the movement. The car will try and resist the forward movement, preventing that tow truck to move, but with the same force here. That's why this one, we can say it's negative T. But these two T's, they will be applied here. And it makes sense because we can play a game. Maybe someone pulls something. We can have a rope that side, a rope that side. Okay, let me draw a scenario again. If maybe we have two people here, and this is the rope, and this one pulls in that direction, and that one pulls in that direction, but they're remaining on the same position. This one pulls with the same T as that one, negative T. Okay, let me say negative T. The very same people, they are pulling each other with the same T. Do you think they will go to the left, or they will go to the right, or they will remain in the same position? Who can tell me? They will go to the left, or they will go to the right, or they will remain in the same position, or if this T is the same. And I get same position. Can I get another one? Is the same position, T left, T right. This T is the same. They are pulling each other. There's two people, left, right. They will remain in the same position, right? Yes. Or maybe let's draw another scenario. Ne? Let's draw another scenario. Let's suggest that we have a wall, and we have our rope, and we have you, or whoever. We have this is your hand, and when you are pulling this rope T, and this is the wall, like it's literally the wall. Ne? You are pulling this T against the wall, you are pulling the rope against the wall. Do you think the wall will move? It won't move, right? Because this T, you are pulling the wall with the certain T, maybe let's say T1, and the wall, what will the wall do? What will the wall do? Not now. There will be a time where I will allow the request. Yes, will not move, right? Because of why? If he pulls, the wall will stop, will have the resistive force which will be applied. Obviously, this guy will pull this with a certainty, but the wall itself will pull back relative to whatever force that you're gonna be pulling this wall to. Like this guy, utlo khoga that tapu ela and hansa khog anga se ifelo, because he won't achieve any movement because of the wall. Obviously, all like the wall is a wall. It's like me trying to push. I'm pushing this wall now. I'm pushing. The wall, this chalkboard, it pushes me back with the very same force, and the very same force in pushing back kayon is the same force that I push the wall with. Like it's first law, second law, and third law. I'm not being specific. I'm not trying to be specific on the law. Am I clear, guys? Yes, in the opposite direction. Thank you very much, Amanda. Thank you very much. I like people who are fixing my English, because we know we're all black people. Ne? We're all black people. So now I want us to look at the things like yes, where is my what? Let me see. Okay. I want us to look at this question. Okay, firstly, we are going to learn about the free body diagrams. I know, guys, we had the rough patch, and congratulations to the ones who passed first term, and hard luck to the ones who are still making it, who are still trying to making it. And I believe those ones who have failed is not the failure of your life, guys. Ne? If you failed now, you still have an opportunity to bounce back. As we are here, you can ask as many questions as you can so that we can help you. So now we're going to start with the free body diagram. Ne? We are going to start with the free body diagram. So before I answer this question, ne? Thank you very much. Before we answer this question, we have to learn. Ne? We have to learn how to draw a free body diagram, because it's very important for you to know how to draw a free body diagram while you do physics. So I'm going to draw a free body diagram of this nice picture of the mother of the son. Ne? The mother and the son. And now it is supported or whatever. It is hooked here, and this picture is just here. And is this picture moving? Yes, we will come on that one. Inclined, yes, we will come on that one. Is this picture moving? Is it going to the left, right, remain the same? Thank you very much. It will remain in the same position because of why? All the forces are balanced, right? All the forces are balanced in this picture. So let's start with the definition of a free body diagram. There's a force diagram, guys. You like to confuse this thing. There's a force diagram and there's a free body diagram. And if I talk about the free body diagram, I'm not talking about the force diagram. A force diagram, it represents the object with the box. And the free body diagram, it represents the object with the dot and the points pointing away from the object. Right? You are more privileged to ask questions. Ne? So now I'm going to focus on the free body diagram before I go to the force diagram. So now I'm representing this picture with the dot. Ne? With a dot. Okay, let me see. I have the allowance. Okay, I'm going to represent this with a dot. Ne? And as I'm representing this with a dot, this is the definition. Let me write the definition of a free body diagram. Ne? Object represented by the dot and arrows pointing away from the dot. Okay, I know over here I have my third law being applied, guys, and I also know over here I'm having my third law, guys. Ne? I'm having my third law. I have my third law, of which is fine because it's free knowledge. It's free knowledge. So now, tell me, is it correct to represent my force like this? Ne? Who can tell me? Is this correct? Is this correct? And you are telling me that you are drawing for me a free body diagram, right? It's not correct. Listen to the definition. The object represented by the dot and arrows pointing away from the dot, guys. This in each and every case is irrespective of whatever chapter that you are doing, whether it's first law, second law, or third law, irrespective of any chapter that you are doing. Ne? Irrespective of any chapter that you are doing, this is not correct. We mustn't find this, because this, it tells you arrows represented by the dot and the arrows represented, no, not arrows, sorry, object. This object is represented by the dot and the arrow, they have to point away from the dot. That's a free body diagram, guys. Before you do things, just know what are the definition. You just have to know the definition. So now we are having this picture. Ne? We know each and every object, guys. Ne? Fn. Okay. Let me emphasize the matter of Fn, because it is not the first time me having the problem of Fn. Guys, normal force is only applied relative to the surface, guys. If there is no surface, there is no normal force. Ne, guys? This guy, is this picture on top of the surface? Is this picture on the surface? Can you please tell me? Is this picture on the surface? Is this picture on the surface? Thank you. Is this picture is not on the surface, guys. It is not on the surface. So since this picture is not on the surface, there is no normal force. Let's agree on that part. It is hanging. Thank you, Wandile. The picture is hanging. Unlike this system, obviously it's on top of the surface. So obviously the force that is acting against the force of gravity is going to be the normal. That's why even the definition, it says perpendicular to the surface. If we have Fn here, which surface is it perpendicular on? Because there is no perpendicular here. There is no perpendicular here. Sisonke. I hope. So now, what I can tell you is that each and every object, it is experiencing a force of gravity. It is experiencing a force of gravity relative to its weight or its mass. Because of each and every object that has mass, it will experience a force of gravity. Yes, please tap the screen, guys. The mass, it means with this picture, it has a certain mass. That's why it is hanging like that. This picture, it was supposed to go down. This picture, it was supposed to go down. But now, there are forces which are exerted in the picture. Now the picture is failing to go down because of it is hanging. It is hanging. It is hanging. Because of these forces here, the picture, it is resisted to go down. Now the picture, it remains on the same position. When it remains on the same position, it fails to go down. No, not kinetic friction, guys. Kinetic friction, guys, normal and kinetic friction, they are relative to the surface. So let's start. Yes, we have tension number 1 and tension number 2. So what is this representing? I want to see what people they are forgetting or they are not forgetting. What is this representing? This is representing what? We are now drawing the free body diagram. What is this representing? Yes, thank you very much. It represents the object. Now we want to know, okay, sharp. We are having our object being there. We are having our object. So the first thing that you have to draw is the force of gravity. Since the picture is hanging like this, obviously the first thing that you have to think of is the force of gravity. The picture, now it's supposed to go down. The picture, it's supposed to go down. What is this force? What is this force? What is this force? Tell me, what is this force? What is the name of this force? Thank you very much. This one is going to be the force of gravity. So this force is going to be the force of gravity. So it means for this picture, it has mass, so it means it has the weight or the Fg. This picture, it has the mass, so it has the weight. So it's supposed to go down, but now we are having the resistive forces. The resistive force and the resistive force. The resistive force, do you see it? And the resistive force. Okay. The camera condemns me. So now I'm going to draw. And let me ask this question. What resists this object to go down? I need the forces that resist this picture to go down. It was supposed to go down due to the force of gravity, but we can see this picture, it's hanging. This picture, it's hanging. Thank you. Thank you very much. Tensions. Tension. Thank you. So in total, I'm asking you guys, in total, how many forces do we have for this system? We are done. After this question, we are done. How many forces do we have for this system? 3 forces. Thank you very much. Now we have 3 forces because we have our tension. Because of the tension is acting on the opposite direction, you will just choose, I'm going to ask a very critical question because of I need you to understand what you are drawing. I need you to know what you are drawing, what you are doing. I need you to know what you are doing and I need you to know what you are drawing. I'm just going to say, let me use a different color. This is going to be TA and TB and TC and TD, right? So between TA and TB, which force will resist this picture to go down? Between TA and TB, because of already we have to draw the T1, right? So I want to know, Hori, between the two forces, TA and TB, because of this is where the third Lloyd occurs, of which is fine, we are familiar with it. Between TA and TB, which force that resist this picture to go down? Because the picture is hanging. Which force resists this picture to go down? Is it visible? This is TA, this is TB. TA, TB. But I think it's not visible because I can see it by the way people they are answering. It's fine. Let me do this. TA and TB. I think now it's possible. Yeah. Up until you give me the same answer. Yes, thank you very much. It's going to be TA, guys. TB is going down. TB is going down. The TA is going up. It is against the force of gravity. The TA is against the force of gravity. So now the force that we are going to draw is going to be, this is going to be the T, the tension. Is it visible, guys? Or should I bring it closer? Let me try to bring it closer. Closer. Okay, and try to quit. Yeah, alright, it's fine. So yeah, thank you very much for answering. We are going to have this TA being drawn, huh? So this is going to be the T1, ne? Between, okay, let me do this. TC, TD. Between TC and TD, which one is going to resist this picture to go down? Thank you very much, guys. Thank you very much. I believe I'm clear. I believe when I explain, I'm going to be clear. This is the TC. Yeah, okay. Let me just say T2. T2. So this is a complete free body diagram for this system. Are we all clear, guys? Are we all clear? Are we all clear? Are we all clear? Can I get a thumbs up? Are we all clear? Thank you very much, guys. Thank you. Now we are going back to this guy. Thank you very much. Thank you very much. So now let's talk about the second law. Let's talk about the objects on the surface now. Objects on the surface. We are going to talk about the objects on the surface. If you need clarity, you can screenshot, and I'm just giving you 3 seconds. 1, 2, 3. Okay, let me shift my face. 1, 2, 3. I believe you are done screenshotting. So I'm wiping, I'm wiping. Yes, thank you very much. So now let's go back to, yes, let's go back. Can you please give me 10K? 10K, guys. Please give me 10K. So now we are going back to this system. We are going back to this system. I'm just going to I'm not going to bring the questions in front. Yes, even grade 11s, they qualify to watch this lesson. Very interesting, very nice and interesting, guys. Very nice and interesting. It's been a long time I haven't been live for physical sciences. I should do justice for my kids. Okay, guys, I'm not going to pose questions and try to answer them, so because I want us to talk and I want us to participate. So now I'm going to come back to you with this diagram, and I want us to draw the free body diagram. Let's start with the car. And remember, when you park hele phaka mo le sa tshwanna mo phakang go teng ba fetho dikoloi tsa lena ba tlo di to ba tlhaloganya and ha ba di to dikoloi tsa lena me I will be there drawing the free body diagram of all the forces that acts on the car, your car that is being towed. So like let's draw for the car the free body diagram, ne? So now I'm going to have the dot, ne? And this is the free body diagram of this car, ne? Okay, or let me just say okay, let me just say 900 kg car. This is the free body diagram of the car for people to get the clarity. So I'm going to represent, and before I jump, ne? Say car 1 and car 2. No, it's fine. This is a car, this is a tow truck, ne? Okay, or maybe let me say car A. You are very correct. Let me say car A and car B. But now it's 900 kg car. Let me just take the 900 kg car, ne? And now if I draw the free body diagram, what do I use to represent this object? What is it that do I use to represent this object? We talked about it just now. What do I use to represent this object? Thank you very much, ne? Thank you very much. We are going to represent this with a dot, guys, ne? We are going to represent that with the dot, ne? So now I need us to teach each other how to think, ne? I need us to teach each other how to think, yeah? So what causes the car? No, not yet momentum, my friend. Today I'm not doing momentum. I'm doing free body diagrams and a bit of calculations and how you analyze questions like that one. So I just want to know, ne? Okay, what causes the car to move forward? I want to ask that question. By looking at this scenario, what causes the car to move forward? Is it this? Is it the applied force? Is it the applied force? Yeah, I want to see this one. I want to see this one. Yeah, I want to see this one. I want to see this one. Hey, yeah. Okay. Guys, ne? What is an applied force? In simple terms, ne? What is the applied force? No, 900 kg car. For 900 kg, for 900 kg, I need the force that causes the car to move in that direction. As this system, it moves in that direction. So I need the car which causes the motion of this 900 kg. That force. It is the string, guys. It is the string, guys. Come on, guys. Guys, ne? Guys, here we are dealing with contact forces. We are not dealing with magical forces. It doesn't cause this car to move, guys. No applied force here. This guy, it doesn't cause this guy to move. This guy, he is responsible for this guy to move. But this guy, it is connected with the string. The string connected this edge and that edge, and that's why we have the tension. So this car, it is moving forward relative to this tension. Can I get a 15K? Can I get a 15K? Remember, what? Okay, let me ask. Last question. I know, guys, people, they are on first time. Let me ask the question. What is the non-contact force that it is always there? What is the non-contact force out of all the forces that we are drawing? What is the non-contact force that we always draw? What is the non-contact force? Thank you, people. Yes. No. Okay. Thank you very much. Force of gravity. Because why? The force of gravity is the force of attraction. banyana hele groove like the ponza you are creating the force of attraction, the non-contact force. So now this, it's like force of gravity is the non-contact force, because each and every object in this planet Earth, it is attracted by the center of the Earth. The center of the Earth, it is pulling us. But let me ask you a question. What is the force that prevents us to not to go down? What is the force that prevents us to not to go down to the center of the Earth? Thank you. Logic. Think about it. We have to think about it. We don't have to. Yes, the reactive force. I need that reactive force is going to be in a normal force. So now you understand, Hori, whenever we have objects hanging, we don't have normal, because the normal, it stops us to not to go down to the center of the Earth. If maybe you're on top of the building, or if you want to prove, Hori, normal it's there on a hanging, jump over the building, jump over the balcony and see how the normal it will pull you up, because you'll be on what? You'll be on what if you jump over? You'll be on what? People, physicists, you'll be on what if you jump over? Because you'll be only experiencing a force of gravity. If the object if the object is only experiencing the force of gravity, it's on what? Free fall. Guys, now it comes to vertical projectile motion, but we are not talking about it, because you're on free fall. You're only experiencing a force of gravity. You're only on free fall. This you'll be on the air, Mara. With the knowledge that we are having on the grade 12, we are neglecting the air friction, right? You'll be on free fall, experiencing only the force of gravity. Do you agree? Are we clear? No, like, guys, ne? Okay, let me be serious, ne? Air is there. We know air is there. That's why we are doing what? We are isolating the system from the air, so that all the system they are just experiencing. Even here, air is there. This, in order for our calculations to be more accurate, we have to neglect the air friction. Because of why? If the car moves in that direction, the air will come as a resistive force. But because we are doing air resistance, air friction, air resistance, air is there, but we are neglecting the air. We are neglecting the air so that we can get our calculations to be accurate. That's why in all cases, when you hold the question paper, avoid air resistance, neglect air resistance, avoid air resistance. Air is there, but we are avoiding it. It is isolated. Thank you very much, Mr. D. When you are correcting my English, I like it, my friend. Yes, that's why we don't calculate air friction. Air is there. Even everywhere, air is there. But let's go back to here. So we are representing this one with a dot. And obviously this guy has mass already. If we see what the object, it has mass. Fg first. Force of gravity. We know what this. It is attracted to the center of the Earth. We have force of gravity. And what is the reactive force for this force? Since it is on top of the surface. What is the reactive force? I'm teaching people how to pass. You can't fail physics while you have me as your tutor. I'm telling you now. Normal force. Force of gravity, normal force. Fg, Fn. You get your first 2 marks of the day. The first 2 marks of the day. So now I'm going back to the question. what causes the object, what causes this car to go forward? 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 Thank you very much. It's going to be tension. This, he has nothing to do with this car. Guys, Fg is the only non-contact force. Fg is the only force that is non-contact. The rest of the forces, they are contact forces. Tension is a contact force. Obviously, whenever the force is applied to this car, it is related, this force, it is related to this object. This object, it is connected to the string. This string is connected to this car, and this car will move forward. Forward relative to what? Relative to this car moving forward. Is that clear? 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 Is that clear, guys? Is it the clear case? Thank you. So now we will have our dot being represented, and I'm asking for the last time. What is this force? I'm asking for the last time. What is this force? Is it F applied? Yes or no? I need a yes or no now. Is it force applied? Force applied? Force applied? Now I'm having the same answers. Thank you very much. It's going to be the tension. It's going to be the tension, guys. I like it. It's going to be the tension. Thank you very much. Now, as we are going forward, do you hear the sound? Do you hear the sound? Listen, I'm going this forward. What is the dragging force? What do you hear? I want you to listen to this. I'm going that side, ne? I'm going that side. What do you hear? What do you hear? Thank you very much. Thank you very much. For the, yes. Friction is the force that opposes the motion of the moving object relative to the surface. Again, we are coming to the hanging objects. Again, we are coming to the hanging objects. Is the force that opposes the motion of the moving object relative to the surface. Huh? Thank you very much. Relative to the surface is very important. Thank you. Utando, bona. This surface thing, guys, this thing of the surface, you should take it to the heart. If I'm having a hanging, hey, you guys, nagela be like about to feel physics for zero. I don't feel physics. Physics is logical, it's nice, guys. We can't fail physics for nothing. So, if I'm having, I'm just going to one question, Inji, quick one. I'm having the picture that I was having. Ne? So, do we have friction in this system? Do we have friction in this system? Yes or no? Do we have friction in this system? Yeah, okay, thank you very much. We don't have friction in this system, right? Since we don't have friction in this system, why are we not having friction in this system? I'm asking, why are we not having friction in this system? Because it is hanging. Yes, thank you very much, Wuntle. Because it is, what is, yes, I needed that one. There is no surface, guys. There is no surface. It is hanging. It's not on top of the surface. It is hanging. It is hanging. Not on top of the surface, guys. It's not on the rough surface. It is hanging and not moving. Thank you. But even on stationary objects, be careful though. On stationary object, we do have friction. But we will come back to that. So, now we have friction. What kind of a friction do we have of this one? It's going to be static or kinetic. for this system is going to be static or kinetic. I need us to be specific. I don't want FF here. I don't want FF, Mr. Wandile. Thank you. It's going to be FK because it is moving. Ne? Because it is moving. So now I want okay, let me fix something. And this thing I don't want to fix it because it will give people answers. I'm going to draw the second free body diagram of the same object. Ne? So I'm going to have tension FK, FG, and FN. What is the difference between these two? What is the difference between these two free body diagrams? What is the difference? What if I write FN? Yeah, it's going to be wrong because of why? The object is moving. It is not on the stationary. It is not on the stationary. It is not stiff. It is moving. What is the difference between the two? What is the difference between these two free body diagrams? Yes, thank you. This one is longer than this one. So what is the meaning of this being longer than this one? Yes, the length of this, it represents the magnitude. It represents the magnitude, and this one, it represents this is more than this one, but this, they are equal. Do you see where these two, they are equal? It means where the magnitude of the tension is going to be bigger than the magnitude of the friction. This one, it means where the tension is equals to the frictional force. So now here's the golden question. Here's the golden question, guys. Here's the golden question. Ne? The golden question says, the golden question now it comes and says, which one is the correct free body diagram? Between A and B. A and B. And Y. Which one is the correct one? Which one is going to be the correct one? I saw this one coming. I saw this disaster coming. Yeah, there's a chaos. A, B, A, B, A, B. But who can solve everything? Who can be the judge of everything? Because me, obviously, I just want to be the one who judges. Ne? Okay, guys. Ne? Okay. To solve this argument, ne? I'm starting again. Now I'm asking precisely which one is going to be the correct one. Thank you very much. Antoinette. Okay. Now let me explain. Let me explain why. Ne? This is going to be the correct free body diagram. Because of this constant velocity, this constant velocity, it's very important. If you don't get that one, are you going to be chowed? We can't say B because the object is moving, and if B is must be Fs. Okay, if we are saying the object is moving with the constant velocity, it means that object is not moving at all. If, like we already said, or the tow truck is moving at the constant velocity, it means it's moving, but at the constant velocity. We learned first law, guys. Ne? We learned first law. First law, all the forces are balanced. Whether constant velocity, whether stationary objects, all the forces are balanced at the first law. So it means, and remember, first law, it means acceleration is going to be 0. And here is this acceleration. Let's talk about the A. On A, is acceleration equals to 0 at A. is here we are having acceleration equals to 0 here relative to this free body diagram. Relative to this free body diagram, we are having our acceleration being 0. So you see where this, it doesn't include this statement. This, it doesn't include this statement. And if this, it doesn't include this statement, it makes this one to be correct. Because this tension, it will cancel out with this K. And now, it means sorry, Ft. Okay, let me write it closer. I like to be closer to the camera. So, it means sorry, Ft. If we are choosing, maybe, let's choose our, is it right on your side? Is this right or is this, okay. Let's choose this direction as positive, right? This direction is positive. So it means that the Ft minus Fk is going to be equals to what? 0. Because of its magnitude. The magnitudes are equal. The magnitudes are equal. So it implies what? Constant velocity. Am I clear? Am I clear? Am I clear? Can I get the thumbs up if I'm clear, guys? Can I get the thumbs up if I'm clear? Aye. Thank you very much. Thank you very much. Thank you very much. Remember, guys, if the forces are not balanced, it means that this system is not moving at the constant velocity. It is accelerating. And as it is accelerating, it means sort of like, okay, let me just wipe this one. We've learned from grade 10. If this, it is accelerating, it means the forces are not balanced. So it's like, what example can I make? Okay, I believe on my, okay, my body's, this body is moving. It's not moving. Yeah. Oh yeah. Yeah, move. Yeah, move. I will do an example. Ne? I will do an example. Ne? If I'm trying to push my board, ne? You see it's moving. If I'm trying to push the board into that direction, I have to overcome the resistive force, right? So whenever I start to push, and if I'm starting to push and push, I'm not moving. It means sorry, the resistive force and the force that I'm applying, they are going to be equal. And they are cancelling each other. Hence we are having this tension and this Fk. Obviously, even though it's moving and it's moving at the constant velocity, it means sorry, the forces are balanced, and which it will implies what? The constant velocity, because the acceleration is 0. It's like having this graph. For this scenario, I can have this graph. Okay, let me tilt my phone a bit. Yeah. For this scenario, I will have this graph. The constant velocity, 2 meters per second. The constant velocity, it looks like this, right? As the constant velocity, it looks like this. How will my acceleration versus time graph look like? It will look like this. A and changing t. This one is going to be v and changing t. A and changing t. It means my graph is going to be on top of what? 0. Graphically, this is what we are representing. That's why we are having the constant velocity. So graphically, it means sorry, the gradient. This is the constant velocity, right? So do we have a slope here? Who can I get a yes or no? Ne? Do we have a slope here? Do we have a slope? What about the direction and the horizontal net arrows? The direction of what? Can you please be specific? Yes, there's no gradient. And what is the slope representing? Because of like here we are having the changing v and changing t. If I want to calculate the gradient, the gradient, remember, is going to be changing y over changing x, which is represented by m. Right? So I'm going to have the changing v. The changing v is on my y-axis, I'm going to have my v, and of which is going to be my v final minus v initial over the changing t. As the time it moves, as the time moves, because the time will never stay in the same. It's ne. My YouTube handle, it's ne. Moderator, come on. It's going to be e, ne. It's Act Tagalane Donald. It's Act Tagalane Donald, guys. Not Mugeri. Come on, guys. Oh, moderator. My YouTube handle is, okay, it's on my bio. It's on my bio, ne? But please, you can fix it, the moderator. But the YouTube handle, it's on my bio. So please subscribe. The whole content will be posted there. Ne. E on the end. On the end, it's E. But it's on my bio, guys. So here we don't have a slope. So we have T final minus T initial, right? So if we are having this, the time will never stay in the same place, ne? No, it's mechanics as a whole, mechanics, because I believe by now everyone it is covered, like everyone it is covered on mechanics. We did mechanics, we know what we are talking about by now. So I'm wrapping up everything and putting it into one special box. So we are having this v final minus v initial, t final minus t initial. Here we don't have a slope, so I'm going to have 2 minus 2 as the time goes by. So as the time goes by, the velocity is constant. The velocity is constant as the time goes by. The velocity is constant. And as the velocity becomes very constant, we don't have a slope. Hence, we are having t final minus t initial, ne? And obviously, even though it doesn't matter the length, what is 2 minus 2? What is 2 minus 2? What is 2 minus 2? It's simply 0, right? So I'm going to have 0 divided by changing t, and I'm going to have my m is going to be equals to 0. My gradient is 0, right? So check something. Ne? This is represented in meters per second, right? It is represented in meters per second, right? So let us calculate the gradient relative to the SI units we are having. So now let me just say m is going to be equals to meters per second, of which is equivalent to what? This is equivalent to, obviously this is equivalent to meters. No. It's going to be meters per second. This is going to be equivalent to meters per second, right? Am I wrong? Am I wrong by representing this like that? Am I wrong? Right? Wrong? Yes? No? We are doing this relative to its one. So now we are trying to calculate the gradient. I want to show you something. So it's going to be meters per second divided by the changing x. The changing x is going to be the changing t. And here is going to be this divided by a second. I just want to show you if you represent it like that, it doesn't matter, it's the same thing. So if I want to represent it, like I just want to show you why the m, why the gradient, it represents the acceleration, ne? I just want to show you why the gradient represents the acceleration. So this is going to be meters per second, my divide by the second. I'm changing this division into multiplication. I'm going to have meters per second multiplied by 1 over second. And this is going to be equivalent to what? Meters divided by second squared. And obviously this is going to be meters per second squared. So what is the SI unit of that one? Hey, let me bring this closer. Hey, this information is very important, guys. Yo, you can't afford to miss this out, eh? What is this representing? Yo, hey, what is this representing? What is this representing? Yeah, what is this representing? Thank you. It's going to be the acceleration. Is the acceleration, which means this is A. Now, if we are having the constant velocity, that's why we are having no acceleration represented this graphically. Guys, kabalabala or ke bolela zero. Lang understand them? Like, can I get a thumbs up if I'm clear? Can I get a thumbs up if I'm clear? Can I get a thumbs up? Because this is the constant velocity, v final minus v initial. This, as time goes by, it doesn't change. It doesn't change, guys. It doesn't change. It's going to be 2 final minus 2 initial. It's going to be 0. It's going to be 2 final minus 2 initial. It's going to be 0. And as we are representing this below as an acceleration between versus time graph, this is going to be on top of this line. And our acceleration is going to be 0. Now let's go back to our scenario, our lovely scenario. Our lovely scenario, guys. Our lovely scenario. Teaching physical sciences without a textbook. Reclaim. Kadala, guys, eh? So, now we are having this guy. Ne? Do you see how y is this b correct? Do we agree on each other how b is going to be correct? It's mechanics, and like the topic is mechanics. Simple, ne? Topic mechanics. Please, moderator, when they are asking for the topic, mechanics. 11 and 12, mechanics. Why? The topic is mechanics. So now I want to do what? So now can I wipe this one? Because this one is going to be useless, right? This one is going to be useless. I'm wiping this one. Yeah, it's very wrong, that one. I'm wiping this one. And here, I'm going to do what? I'm going to do what? I'm going to say 1,300 kg. No, re bolela ditaba tse serious. Yeah, here's the scenario. On top, there are no questions, there are no scenarios, there are no questions. We are just jogging our minds. We will come back to the questions. We are jogging our mind. So now, obviously, what am I going to represent my toe tag with as I'm drawing the free body diagram? We are going back there now. What is it that I'm going to use to represent my toe tag with? Can I get an answer? Oh, moderator, unfortunately I can't pray. I have to introduce this topic. I will pray at 3 o'clock. People that are interested, I have to help them. I will pray at 3 o'clock, moderator. Please, man. With the dot, right? Represent this one with the dot. So, since it has the mass, what is the first force that we have to start with? What is the force that is relative to the mass and at the same time? That force is a non-contact force. That's the force that we start with. which is going to be FG. It's going to be the FG, right? Thank you. So it's going to be the FG. So since it's going to be the FG, what is the resistive force for FG? I thought you were saying wait, my friend. I nearly waited. Yes, it's going to be normal. Okay, I want to ask a very simple question, guys. Why are these two forces equal in magnitude? Why is it like that? Okay, let me draw it straight, okay? Before people kill me, let me draw it straight. Okay, is it straight enough? Yes, thank you. No upwards movement, Anger. No upwards movement. So now, what is the force that causes this guy over here to move in that direction? What causes this guy to move? What is the force that causes this guy to move in that direction, guys? Applied force, right? It's going to be the applied force. Now, what is the force that resists the motion of the applied force? Yes. It's going to be okay. I want to clarify something. Thank you very much for answering, and I want to clarify something. So now I'm going to have, guys, don't judge me. I want to see people who they are logical, because the free body diagram that I'm going to draw here is very critical. So I'm going to have, okay, let me do this. I'm going to have friction, and what is the force that is left which behaves as the resistive force? Obviously, how many forces that we have which they act as a resistive force? Okay, obviously it's going to be tension, right? Okay, let me just do this to be a little bit short. It's going to be Fk because of its moving. Now I'm going to have, okay, going to have Ft. Now the last question. The last question. What is wrong with this free body diagram? That's the question, Isham. What is wrong with this free body diagram? No, never mind the length. The length is fine. Trust me. We are not drawing this up to scale. We are not drawing this up to scale. The length is fine. Leave the length. Because we are not drawing this up to scale. I want to see for people. What is wrong with this free body diagram? I just want to give you 2 minutes to yes. Okay, I think okay, arrows, okay. No, the arrows are fine. Mara guys, we have analyzed everything together, ne? But now I'm asking you, what is wrong with this free body diagram? Okay, Ria, what's wrong with FK and FT? What's wrong? I think Ria is coming with something. Ria, what's wrong with FK and FT? She's just saying Marangar. I thought she's coming with something, but I don't know. What is wrong? Yes, okay. Let's give you a platform, famous TikToker. Welcome to our live. So let's give you a platform. What is wrong with this free body diagram? Trust me. Okay, the minute. In the meantime, please tap the screen. Tap the screen. Tap the screen. Tap the screen. Can I have 35, 35, 35, 35? The minute is ending now. And I'm going to come forward. And what I'm going to explain very now is very important. And some people, they are saying, oh, Marai. Yeah, thank you, Ria. Guys, FK has to be on the bottom and the FT has to be at the top. Even FK the FK is reacting relative to the surface. It has to be beneath FT. The FT is above, guys. One Talohain. Okay, my apologies. I didn't see that comment. My apologies, guys. Like, but if you got that, Hashem, you're on the right track. You're on the right track. FT, it can't be beneath FK, guys. FT, it can't be beneath FK. Mara ulatelwe. Guys, FK, bon. My friend is pulling me, ne? My friend is pulling me. Hey, Asamba TK. Where do you hear the where is my pulling force? My pulling force is here. The force of friction is down there. But whenever you draw a free body diagram, you want to draw the F friction here and the pulling force down there. It doesn't make sense, guys. Huh? Like, but do you get what I'm trying to say to you? Or maybe I'm going this side, ne? I'm going this side. Someone is pulling me. Like, the friction, it's on there. It has to be beneath. That's what is wrong here. So whenever I'm going to draw this, be careful of such. Huh? So be careful of such. So you have to have your FT here. FT and FK. Now it makes sense. Now it makes sense because of this. It is acting relative to the surface. It has to be beneath. Do you see the T? It is above the surface. And the FK is acting here. It is below. It is on the ground. It is on the surface. Huh? Like, do you get what I'm trying to say? Thank you very much. Thank you very much. Thank you for the compliment, my friend. Thank you very much. Thank you for the compliment. Huh? Science. Like, that's what I'm saying to you guys. Or this is physical sciences, guys. It is nice. It is physical. It is not emotional sciences, guys. It is physical sciences, guys. It is not emotional sciences, guys. Huh? Guys, thank you very much for joining my live. You guys are making this very interesting. Ne? Now let's go back to the question. Ne? Let's go back to the question. I'm coming. I'm going to fetch the question for this one. Because obviously the question, I didn't want to pose like questions like a boring teacher. No. Already we've answered the question. The first question is determine what is the frictional force. Already you can tell me what is the definition of the frictional force. Thank you very much, Kamo. Thank you very much for the compliment. Thank you very much for the compliment. Like, with the activities, with whatever that I just explained now, I tell you now, ne? I tell you now. The very first question, they will tell you, define the frictional force. Or you already told me what is the frictional force. 2 marks on your pocket. what is the law that says it opposes the motion when force A acts on force B and force B will oppositely act on the force A, and we talked about that, which is the third law. If I push this wall, the wall will push me back. I just told you now. One is the third law. 2 marks on the pockets. One again, we talked about what? We talked about the free body diagram. They will ask you, draw the free body diagram of these two systems. Why should I be the boring teacher? Or should I do what? 4.1.1 okay. So now we are coming to calculations now. We are coming to calculation. Thank you very much. Hey, thank you very much, moderator, for coming back. Thank you for coming back. Like, share, and follow. Please subscribe to my YouTube channel, guys. Subscribe to my YouTube channel. And can I at least have 10 people subscribing on my YouTube channel, guys? I also do math. I also do physical sciences, and I believe already me having this board, thanks to your support. I'm having the board. I'm having what. Yeah, I'm not a professional teacher, my guy. I'm still on the way there. I'm the degree teacher exposer. Hurry. Please go to my bio. I'm a degree teacher exposer. Or there are some teachers who just have their degrees, but I wish they would have just, because what I'm explaining to you is the things that I wished I've been like. The character that I'm bringing to you is the character that I've been seeking for the longest time, but fortunately I bring this to you. So I want the question. Let me look for the question which involves the calculation. And I hope for now it's going to be easy. I'm coming. All right. Give will. Now they gave us. Okay, 0.45. Now they gave us the. They gave us tell us the secret of studying of physical science. Guy, join my private session. DM me on my private, yeah? No, we are not saving any time, yeah? We have to. DM me if you want to be a professional, if you want tips, if you want what, DM me. I'm charging 200 per month for the private sessions. 200 per month for the private sessions. It's very cheap. Where now you take that 200, you buy McFeast. Then you go to the toilet. Story child. So now we are given the information the coefficient of the friction between this tow truck and the surface. The coefficient of the friction between the tow truck and the surface. So the coefficient of the friction is going to be equals to 0.45. Ne? It's going to be 0.45, and as it is 0.45, we have to calculate what? We have to calculate this guy, huh? Please like, share, and follow. Please like, share, and follow. Follow, like, share. Please like, share, and follow. Yeah. and I'll throw length make fist. Gilifile ngave, gilifile yo. So now we have the coefficient of the friction. Yeah, we are calculating. No, not necessarily simultaneous. Not necessarily simultaneous, my friend. Sometimes, whenever you want to analyze the questions, just look for the facts. The facts that will help you to get into the answer. Remember, we have the constant velocity. And if we are summing up all the forces here, what is the F net? Can someone give me the F net? Let's be busy now. Can someone give me the F net? The F net for this. F net is going to be 0, right? Thank you. It's going to be 0. So that's your first thing. That's the first thing that you have to think of. If I have the constant velocity like that, the F net is going to be 0. So now, what am I going to do? I'm just going to say, okay, let me tilt. I'm just going to say the F net. Now we are choosing that direction as positive, right? So as we are choosing that direction as positive, we are going to say F net is going to be equals to F applied and plus negative Ft plus negative Fk. Ne? Thank you very much. Thank you very much for the gift. Thank you very much on this one. And I hope this life works for you. So now, as I'm having this, thank you very much for the gift. And I hope God will bless you for your journey of learning, guys. Ne? I hope God will bless you. And as you are gifting this channel, I promise, this, it will be effective. I will be as slow as possible. Try to engage with each and every comment. Yeah, thank you. So we are having this. So our F net width is going to be 0, right? And guys, we are not calculating for a specific question. We are calculating for everything. Not necessarily everything, but we are looking for tension. Ne? So now, as we are having that, so what is my F applied? What is my F applied? What is my F applied? My F applied is going to be what? 9,000 newtons, right? Let's go back to the camera. So now we are going to have our 9,000 newtons minus. Thank you very much. Minus, we don't have. Okay. How will this coefficient help us to get? What can we get out of this coefficient? If you studied your what very well, how is this going to help you to? Yes. How is it going to help you? Yes, to find the kinetic friction, right? Because of why? We have the formula. God, I forgot that formula. So it's going to be Fn is going to be equals to, no, sorry. This is the ratio. It's going to be, is the ratio of what? Is it the UK is going to be equals to what? Is it N on top and Fk on the bottom, or is it Fk or one salon? Oh. So is it F? Okay. So is it N on top, guys? Okay, give me the multiplication one. So let me just say Fk is gonna be equals to the coefficient of friction multiplied by N. It's like this, ne? Is this the formula? Is this the formula? Yes, no, yes, no. Is this the formula? Thank you very much. Yes, thank you very much. So, now how can we get our n? So we know that our n, this is the horizontal surface. So since this is going to be our horizontal surface, so this Fn is the resistive force of Fg. In order for us to not to go down to the center of the surface, is because of this guy. Let's clap hands for Fn. Fn is doing just this. He's saving us, all of us, to not to go down. Fn. So Fn is going to be, this is going to be equivalent to what? Fg. So now, since this is the equivalent for these two, they are equivalent, so Fn is going to be equals to mg. No, let me start with the correct language. Fg, and Fg is going to be equals to mg. So Fn is going to be equals to mg. So this Fn is going to be equals to mg. OMG, OMG, mg. So with the Fk, so we can get Fn of this 1,3 newtons. So let's get Fn. What is the value of the Fn? 1,3 times 9,8 is going to be what? Let me start on the clean slate with my girlfriend. Fn is going to be 1,300 times 9,8, which is going to be what? This is going to be what? I don't have a calculator on me. Damn it. Let me bring this closer. Let me bring this closer. Yeah. Thank you very much. So Fn is going to be, what is the value, guys? 12,740. Is it okay? 12,740. Is this correct? Is this correct? Is this the correct value? Oh, thank you very much. Thank you very much. So this is going to be in newtons. So now we don't have Ft. So we substituted the F applied is going to be the 9,000. Now we got the Fd, and yes, upwards. Okay, upwards, since it is a vector quantity. Thank you very much for that information. Since it is a vector quantity, it has to be upwards, but that's not the main thing that I'm looking for, because most of the teachers, they are focusing on the the final answer, the direction of the final answer. Mara, it's fine for you, for the sake of the knowledge, is going to be upwards. Thank you very much. Ne? So this is going to be newtons upwards. Ne? So now we are going to have our Ft. So now, what is our Fk minus? What is our Fk? We have to calculate for the value of the Fk, right? The value of the Fk. So the value of the Fk is going to be what? The value of the Fk is going to be what? We are going to use this formula. This one. Ne? Yes, thank you very much. It's going to be UK. The the coefficient of the friction multiplied by the normal. The coefficient of the friction is going to be 0,45 multiplied by 12,740, and Fk is going to be equals to what? What is my Fk? I don't have a calculator. What is my Fk? What is my Fk? I like my, so is it 57,000? Is it 57,000? Oh, 5,733. Thank you very much. Ne? So guys, this is my left. I'm not sure what is this direction for you, but this is my left. But I will just choose Okay, the direction. Oh, I will just say forward, ne? For the direction. I will just say forward. So Fk is going to be 5,733 newtons to the opposite direction. I will just use forward and opposite direction, ne? Because I'm not sure, because my screen is mirrored and I don't want to. I'm not sure which is which. My screen is mirrored. I'm not sure. I don't want to. But I will just say opposite the forward direction. Let me just say opposite. Ne? Mus, we are cool. We are cool with this opposite. We are cool, Mus. Can I get a thumbs up? Oh, okay. So, now since I'm having this answer, I'm going to put it there. Ne? I'm going to put it there. I'm going to put it there because I know what my FT is the one that I'm looking for. So now in place of my FK, I'm going to put negative 5,733, and of which is equals to 0. Ne? And now what do? We are solving for the tension. So basically, now we are shifting our minds from the physical science. We are moving to maths. We are becoming mathematicians. Yes, the direction of motion is positive to maths. Transposing from to mathematics. So now, no, we are not transposing. Oh, what is 9,000 minus 206? 9,000 minus 5,733. What is the? Not yet simultaneous. Like, guys, don't rush to simultaneous. We can easily get T. We can easily get Ft without doing any simultaneous. Because remember, this is traveling at the constant velocity. So this is going to be what? Is going to be what? What is the answer? 3,267. Thank you. 3,267 minus Ft. Is that 3,267? Is it negative or positive? Because I can see some people, they are posting the negative answer. And of which is equals to 0. Is it positive, right? Thank you. So now I'm just simply going to transpose this guy to that other side. This Ft to that other side to change the direction. So I'm going to have my Ft being what? 3,267 newtons. Which direction? Is it opposite? Yes. Oh, yes, opposite direction. Opposite direction. Let me just write opposite because whenever, yeah, right. Because whenever I use, if I use left and right, I will fight. I know. I don't want to fight with people that I know or these people they support. Come on, guys. We are done with tension. And what is the next thing that we have to calculate? Let me check. Let me check. We can calculate what? We can calculate just write opposite the direction of the motion and also modulo tloelang left le right bafethu, tloelang left le right, ne, opposite o tswe mo dilo. So now yay Sunbane, Sunbane. Das. Sunbane. Ow. I was having this thing. I was having the wipery. Now I'm lost. So now I want to calculate the coefficient. Ne? I want to calculate the coefficient of this friction. No, we are not done. We want to calculate the coefficient of this friction. Ne? Because now we got our T. No, the A is not equals to 0 because there's a question that I will ask after this one. Ne? After this one, there's a golden question that I have to ask. Ne? And this one is very interesting. And I will ask you to stay put for this kind of the question, because now I want to calculate the coefficient of the friction between this and that car. No co-hosting. I don't co-host. Don't want to co-host. I don't want people who will disturb the learner's education. People wants to play games. I rather game. I like. Na go ya bala ba fit. Harabali. Toleng di. A re bere ke ka tlotsi. Rabala. So the coefficient. Yes, no. FK, okay, I see you, famous TikToker. Don't be afraid to call out the answers, ne? So now, what is if I sum up these things, what will I get? What magnitude am I going to get if I sum these things? What magnitude? What is the magnitude that I'm going to get if I sum these things? Is it 0? 0? Because why? Still, the object, it still moves. Thank you very much. It's going to be 0. So now, what are we going to do? We are going to look for the value of this. So tell me something. What is the value of friction, guys? What is the value of this friction? We don't have to. We want to by the looks of things. By the looks of things, I need the value of this guy. What is the value of this guy? Thank you, Minga Teko. Here, this FK. The FK that I'm pointing. This FK. Because here's the system. Here's the system. We got the value of this tension. Now I need this FK. Now I need the value. What is the value here? What is the value? What is the value here? I want to see this one. And let me cock a bit. What is the value? Okay. Let me do it, because people they are skeptical. They are scared of themselves. But these are two free body diagrams. Ne? Oh, sorry about that. These are two free body diagrams. Ne? These are two free body diagrams. This is the free body diagram of that one. I want this light. Like good. These are the two free body diagrams. Ne? Now I'm looking for this friction. Ne? Now I had that value. Here's the value. We got it. And get now when we sum these two, they are giving us what? Because whenever I choose this direction to be positive, can't what am I doing? So when I sum these two, they will give me what? Obviously, I will say F net is going to be equals to T, because that direction is going to be positive, right? So it's going to be T minus Fk. So what is the value of F net? Who can tell me the value of F net? Tell me the value of F net. What is the value of F net? F net. Thank you. The F net is going to be 0. So since the F net is going to be 0, what is the value of t? What is the value of t? The value of t? Can I have the value of t? Can I have the value of t? 3,267. Thank you very much. 267 minus fk. I transpose this fk to the other side. So I will have fk being equals to 3,267 newtons. Simple. Guys. Come on, guys. Come on, guys. Come on, guys. Or like you act. Hey, mafethu. Hey, mara lena ka le rata, wait. I hope len rata back. So, what is the coefficient now? I need the coefficient of this car and the surface. I wanted to use Fn, but thanks. Yeah. So, cause this, as this constant velocity, it works over and over. Which part? Please be specific. If you are lost, please be specific, ne? Please be specific. As we are waiting for Big Mama. As we are yes. No crying emojis, guys, please, ne? No crying emojis. I need you guys happy. If you are crying, TikTok will no crying emojis, ne? So I'm going to have fk going to be equals to uk multiplied by normal. So how can we calculate the normal? With vectors, my dear, I prefer you to DM me. Guys, if you know or you need help, DM Mr. TK. He charges 200 per month. For this whole content. Thank you. So, grade 10, grade 11, grade 12, I do them. Same price. No difference. Same price. 200. You can come to my DM. Yes, is it online? Online. Very productive, very cheap. I'm not an opportunist. I provide. Yes. Is it 100% guarantee? Come on, guys. Do you think what I'm talking, do you think I'm lying to you? Do you think what I'm doing here, I'm playing, my friend? Do you think all these things, they come from, come on, guys. No. Yes. So, what is the FK? It's 3,267. Because basically we are done with this question. That's why I'm relaxing. You should relax, man. I'm telling 3,267 in UK multiplied by the normal. How can we get normal? These two forces, they are equal to each other. And obviously this and that, they are equal. So in order for us to get normal, mg 900 9,8. So what is the value of the normal? What is the value here of the normal? What is the value? What is the value? What is the value? Can I have the value? Can I have the value? Can I have the value? Thank you very much. 8,820. Thank you. Thank you. Which part should I double check? Which part should I double check? Oh yes. It means your answer is right, Mrs. Kali. I ngathi lo akezwa moderator uze ngama what. So 3 2 and what. So this is going to be 800 and what 20, obviously divided by 820 8,820 for both sides. This cancelling that. What is their value here? What is the value? It's going to be 0.37. Thank you very much. Guys, the coefficient, it doesn't have a SI unit. There's no SI unit when you are dealing with the coefficient, guys. No. There's no newtons in the SI unit. We are having no SI unit. Yes, because of you are dividing two forces. We are leaving the answer like that. So the forces will cancel each other and the answer that you're going to get, yes. Okay. Because this is the force N and this is the force N. This force will cancel out that force. I'm not sure if it's visible like that. Well, thank you if you understand, Mr. Tar. Thank you very much. So now, guys, since we have, so here's an interesting question. I know we are covered and we are all covered and we are all nice and we are all ne? Now I'm having an interesting question. Ne? I'll show Mr. TK. Wazwagala. Ne? Wazwagala. Ar. Wafit. Kaskero sahai. Wa level. Ar. Kwe. Lemon we're like. Ar. Kwe. What will happen to this car? Oh, lemon with the TK we're like. Ufitila saying. Ar. Kwe. What will happen to this car? Yes, obviously. No, guys, not stationary. Niketelo, come on. Not stationary, my friend, but I will explain now. Guys, the string, it break. No, I broke the string. I came with my kamis and said, Kai roba this thing. Kai robona. Kai cut this system. The car will move. Yeah, Mr. Tar. That's the right term, my friend. Thank you very much for that term. Yes, I cut with my camisa and the car will move forward, but it will move up until it becomes to stop. It will come to stop. But it will move due to what? What will make this car to move forward? Because there's no one in the car. What will make this car to move forward? It will move up until it becomes to stop. I saw Mr. Dlamini. I saw Tyreek. Yeah, my friends. It will move due to inertia. Kilo wana ko training we rang. Hey, move. It's sweet. Hey. Sorry. What training? Askirli ragam ko. Ah, la wana. Hey. Sorry, wala. Atlaloi. Kam kolira again. Yeah, ki Newton slow, my friend. My itus. Ko training lira ya. Yes. Cause why? the car, it was adapting to the constant velocity. Like koloi ne adaptile, like it adapted to that constant velocity. And as it adapted to the constant velocity, like it was moving. It was moving, but I came na Mr. TK ka destroy attention ke fitlhela ka re kwe one first time. It continues with no, it will no. That's why I'm saying hore as it got used. It was used to travel with that constant velocity. That constant velocity. As it was moving, but it will move. As and it will break due to friction. You're still correct when you say friction. You're still correct. Because the free body diagram now, it will look how? Which one? Okay, yeah, is this one. It will look like how? How will it look like? Okay, let me just wipe which part. Let me wipe this part. And this part. Because I'm no longer needing this part. Yeah. But this one I will need it. FK and this one also, which is T. So which means I will be having no tension. And the tension will no longer be there, guys. Now my free body diagram is like this. Here's the good question. What law is this one? I want to ask a very critical question. What is this law? What law is this one? What is this law? What law is this one? FN. Thank you. What law is this one? Yeah. Because is the law of inertia, guys. The first law. The law of inertia. Because of the object will maintain its velocity by going forward for that moment. Yes, for that moment. But it will eventually decelerate. But the moment it starts to decelerate, because of the acceleration, get this one. This object is decelerating. It means it is acceleration. Hey, Rolly, thank you very much for joining. Thank you very much. So the moment it is stopping, due to this friction, now it's accelerating in that direction. So there is an acceleration. But because of inertia, yeah, understand? Because of inertia, it will eventually stop. So now, let's go to the 1,3 track. We are done with this one. Let's go to this one now. What law are we going to have? Because obviously, we are no longer having tension. So what I will do, I will just do this. And I will just whip. Now what will happen now? Now what is going to happen? What is going to happen? What I like, I'm drawing the picture in your mind, guys. It's like I'm taking your mind, I'm bringing it. Hey, I'm drawing the picture, guys. You have to see the picture. Now this one, it becomes the second law. The coefficient of the here I have interesting questions now. That's why I like physics, guys. Oh wait, bafethu. Ngiyashona marangshoni. Marangshoni ungawa. So now the coefficient will change. This guy will change. This guy will change. Will increase, decrease, or remain the same? This guy will change. Will this guy change? Now we're having this. We are no longer having tension. This tension is out. Askere ke fitlhile nna ke le Mr. TK ka re qo ka Makhamisa ka re qo. It will remain the same because of why? Can I ask you, is it possible to change the subject to science after metric on NCS? Maybe. For this type of questions, please DM me. Ne? We'll talk about it because I don't want to disturb the lesson to talk about the process. What? Ne? I would like you to DM me so that we can talk about that. Yes, depends on the it depends on the content of the surface. This is the content of the surface. It's like ne coefficient of friction, guys. Ne, if you didn't know, ne, if you noticed, yes, it's grade 11 and 12. Grade 11 and 12. If you are here doing the grade 12, don't fall off. If you notice, guys, ne, honale go home when the highway. Honale go home more tsamayang the track, more especially where there is heavy metals. There's somewhere maybe you will hear where the surface is rough. Or sometimes these are for the objects these are objects that are large with lots and lots of momentum, because whenever an object has more momentum, like it means it will take time to stop. That's the lesson of another day, momentum. Because or maybe if sometimes maybe like you would say, or maybe if the bus it struggles to stop, there's a sentinyana. It's already like please correct me. Drivers, there's a sentinyana, and whenever the driver tries to stop, maybe he moves to the side so that the sand it helps the driver to stop. That's the coefficient of friction. And again, obviously, you'll get sometimes you can see the surface is not the same in streets, more especially in highways, and more especially on the way where large cars where they move, like where they struggle to stop. Obviously, there's a because if you have more of this coefficient of friction, obviously the truck will stop. Because imagine a truck moving in the smooth surface and it tries to brake, or the driver tries to brake on a smooth surface. How long will it take for that truck to stop? How long will it take for that truck to stop? And I hope you get this one, But yeah, so the normal force is directly proportional to the kinetic friction. Yes. According to the formula. Yes. Yes. Hey, but let's focus on our question. So since we are having the second law here, we are now calculating for acceleration for this truck. Now we will have to calculate the acceleration for this truck. So as we are calculating the acceleration for this truck, I'm asking again, will the friction change? Will this value of the friction change? Will this value of the friction change? Can I get a yes or no? Will this value change? Thank you. Friction is friction. It won't change. Ne? Now this object, it is accelerating. Ne? Now, will my F net be 0? Will my F net be 0? Here, in this scenario, will my F net become 0? So now you can see now the length of the free body diagram. It tells us, it goes back to that thing, guys. The length of the free body diagram. It's now unequal. Ne? This length will not be equal to that length because of like why? We nqamuled. We nqamuled. The acceleration. So that length le angeke saba equal na le. So now we will have F net is going to be equals to MA. Now we are here now. Now we are here. This is the formula of which law? Let's remind each other. This is the formula of which law? Yes, open classes. Yeah, we nqamu. Phela sikhulu isilungu siyakhathaza sometimes bafethu. Ngingangiblame. Isilungu siyakhathaza bafethu. Yes. Phela ukukhuluma isilungu korokota. Awu. Unfortunately, so this is for second law, right? We agree. So remember, from grade 10, we have this as an applied force, and our applied force is going to be what? 9,000 newtons, ne? 9,000 newtons, and this Fk is going to be 500 and what. So now we have to get the sum of the F net. Guys, ne? Because people, they have a tendency of taking this applied force. Thank you very much. Eh? Thank you very much for the compliment. Like, ne? Guys, people, they have a tendency of it's 11 and 12, my friend. People have a tendency of taking this applied force. This applied force is not F net. This applied force is not F net, guys. Please don't confuse the two. Okay. Yeah. This applied force is not F net. The F net is the net result. Like, guys, re nyaka net worth ya ha aske re la itse re rena jo re rata calculator the what you call the amount tsa batho re net worth ya motsepe net worth one frostan. So net worth, obviously, let's talk about the net worth kancane nje. If nifuna net worth yami nizo calculate ukuthi okay, hayi not yami enhle mina ngichaye kakhulu. So yaka motsepo no mine, motsepo on KFC, no motsepo on business group. So is by KFC plus chicken leg plus what zonke mesihlangene iba in net worth. Fana nalo iba in net force. So sihlanganisa honke ama force la acta horizontally. Oh, no, sorry. Sorry. Lo akekho nqamulde bafethu. No. Like which grade? Cause what would see now and then? No, it's grade 11 and 12, guys. I wonder if you know how you have this content in your context. Just know how to like attend, man. If you know how you need this knowledge, attend, cause it's 11 and 12. In grade 12, they have this. So the F net is going to be equals to, we choose the direction, but I like to choose the direction of the force as positive. So I'm going to have this direction as positive. So I'm going to have the F applied, ne? The F applied this F applied since it goes to that direction. And what is the resistive force? How can I write this? How will I write my friction since it is a resistive force? Since it is a resistive force, how will I write my friction? It's going to be positive friction, right? It's going to be a positive friction. Positive. Positive. Is it a positive? Yeah, it's going to be the negative, guys. Ne? It's going to be the negative because of why? It is resisting this. Like what? Le friction. The thing, the sound that you hear, guys, is going to be the friction. It goes in the opposite direction. So it's going to be negative friction. But let me write it the correct way. It's going to be plus negative Fk. So what will I substitute my F net with? I will substitute my F net with because I know where my F net is going to be what? MA. F net is going to be MA. So I'm going to have my F net being MA being equals to 900. Oh, not 900, 9,000. And plus this value of the friction that we got. So this is the value that we got for friction. So negative 573 5,733. So I'm going to have what? I'm going to have 1,300 A. And what is the sum of these two? What is the sum? Can I get an answer here? Can I get an answer for these two? Can I get an answer for these two? Can I get an answer for these two? Can I get an answer? Oh, 3,000. Okay, it's going to be 3,267. So it's going to be 3,267. Yeah. Then and 1,300 going off, and our A is going to be what? What is going to be the value of the acceleration? So it's going to be 0, comma, what? Can I get a verification? Okay, 0,02. Not newtons, guys, not newtons. I said newtons. Kitty meters per second squared. This is an acceleration. Then we are done with this signal. We can clap hands. Clap hands for the. Let's clap hands for all the forces that participated on this system. We can. Yeah. There's something wrong here. People, they're giving me wrong answers. Come on, guys. Is this the right answer, guys? This is not the answer. Yeah, I had a feeling because this value is greater than this. Come on, guys. Glad faith. Sleeping. You practice how to border. It's going to be 2,51 meters per second squared. Yes, this is the correct. Yeah, this one I believe is the correct answer. This one. Yes. Yes. Thank you very much. Now we can clap hands for all the forces that participated on this system. Participated all the forces that participated in this system. As we enrolled, and we joined, and we had all the forces that participated. Yeah. Yeah. It's working. It's working. Don't worry. It's working. It's working. It's working. Thank you very much. Can I have the... Yes. Yes, comment. But only positive comments, guys. Only positive comments. I don't take negativity. Wabo. We can joke. We can do whatever. Wabo. We can joke. We can do whatever. Singakhuluma ngomjolo. What. Mara hayi. Angifuni anything ezo discourage. It's a vector quantity, my friend. It's a vector quantity. Yeah. Because of why? Yes, let me ask the golden question. Thank you very much, Luva K, for that question, my friend. Thank you very much for Lu. So, what is the direction for this acceleration? What is the direction here? What is the direction for this acceleration? You can even determine the direction of acceleration with your free body diagram, with the length of your free body diagram. Yes, it's going to be left, right? Left. Now it is complete. Because the vector quantity is the quantity. Yes, thank you very much. The vector quantity is the quantity that has magnitude and the direction. And this is a 2D chemistry. Hey, I moderate. Now, how do you draw a force diagram? Oh, the force diagram. The force diagram, it's simple, like okay, for which object do you want me to draw a force diagram? Let's assume that okay, now let's cool off, ne? Yes, we can do chemistry. Yes. Let's cool off and draw the force diagram and talk a little bit more about the... Yes, we can do chemistry, but not now, on weekend. And like I will see how do I prepare for chemistry. Oh, sorry about that. I want to show you the difference between the force diagram and the free body diagram. When are you going live? This is the midnight session for Mr. TK. Every time at 12, but this week I started today to go live at 12. But yeah. So it would be good to have the head start. We'll remind each other everything, don't worry. So let me draw a force diagram for this guy. So the difference between the force diagram and the free body diagram, ne? The force diagram, it represents the object with the square, ne? Because let me start by drawing the small surface like this, ne? And I'm taking this object down. Like, okay, we are done with the activity. I assembled the cables, ne? Now the tension is back, but we are no longer answering the questions of the questions, ne? So now we are going to take this and represent it with the box like this, ne? And now we want to do what? We want to represent all the forces which acts on this object, on this box, ne? And now you should remember that you should know everything. That, like, you should know every force and where does it act, ne? We have our force of gravity. Force of gravity, it acts from the center, from here, going down, ne? From here going down. Because is the force that is exerted is the between their centers. Between two objects, between their centers. So this force of gravity is acts from the center to the center of the globe. Right? And then now we have the normal force, which is the resistive force. It's acting from where? Am I going to, and I want to ask this question. Do I have to draw my normal from here, center? No, we are brushing up. We are brushing up. Just be open-minded. One delay. Be open-minded, my friend. So I'm going to... Yes, thank you very much. Because of why? The resistive force, it is acting relative to the surface. Ne? It is acting relative to the surface. So as we are stepping... Hey, moderator, hey, labantu lava. Upload your lower tube. What Hey. Thank you. So we are going to draw this relative to the surface going up. This is from the center to downwards. This is going to be our FG. And the FG, obviously, I told you with the picture. Ningaba entertain abantu abaso, ningaba entertain. Balimele, yibo laba sithi balimele, yabo. Balimele, akunanto bangayenza nge-TikTok. Badlala ngedatha nje. Ngabathathi serious, ngabathathi. So from the center to the center of the earth. So obviously the resistive force, it acts relative to the surface. So it will act from the surface and upwards, and obviously it has to be perpendicular. Ne? So this force is going to be the normal force. So now you can see here, obviously this is the engine, and the engine is positioned where? Here, obviously. It pulls this thing, obviously. You accelerating with the engine. So with this engine, it causes this applied force. You can even draw it from here to there, and this is going to be your applied FA. Ne? Friction, it is acting relative to the surface, but the saddest part about friction, friction so the friction is acting from surface. Because of why am I drawing it on top of this surface? Because of friction, it's acting relative to the surface. So this is the force diagram. This is how the force diagram looks like. Oh, tension, right? So the tension, it's acting from where? From here. Or somewhere more. Somewhere more. Okay. It's fine. The tension is acting in that direction. Oh? Yes. It is 90 degrees, not degrees, my friend. 90 degrees. So this is how the force diagram for this looks like. Ne? What is the difference? Let's draw the free body diagram. And guys, anthanda kumdrawa le dot le ningayidrawa yabangaka. You still correct. Ngicolore kahle, ngicolore ngithi besithi ngidrawile dot yami. Uyabona ukuthi inkulu kanjani? I've drawn my dot. You see how big it is? Because I want to represent the forces that are acting on this object. I'm still going to draw the very same forces, but you see what is the difference? The force, this one, It doesn't matter, because okay, imagine if you are drawing it. Well, you know why I'm drawing it to be big, ne? This is an object. Imagine if you are drawing it like this. How are you going to represent tension and friction in something like this? You are going to say tension, friction, like you see, and you're like do you get what I'm trying to say, Mar? Mara, rather than this one, I'm going to say tension and friction. Wabon, do you get the logic? Like, do you get what I'm trying to say? Make this dot to be big so that you can freely draw your forces. Thank you very much if you understand. Because you see your like the dot is here, but you are going to fight, or maybe you guys are you are artists, you are drawists. You are still going to no man. Draw this dot to be big, to be visible. Because they won't measure the size. Even when they mark, do you think what they will come here or they will say, they will take a tape measure and say, oh hey, okay, this one is bigger, it's big enough to represent the object, so let's give him a mark. They don't do that. So so now we are going to have this guy being the tension, and we are going to have this guy being the friction. It can be FK, it can be what. It depends on the force that you want to, like, it depends on the object whether it's moving or it's not moving. So you'll have your F applied freely like that. And imagine, coming back to that small dot of yours, you will just do this, ne? And you do something like this. Then you come back and draw your force of gravity, and you draw it like here. You draw it here. Do you see this? Do you see what this thing is not on top of the dot? The danger, ne? I'm going to come to your question, Geneva. The danger of drawing the small dots. Because now this thing is no longer on top of the dot. That's why I require you guys to draw the big dot so that you can see. So the difference between the FF, this is friction, it's normal friction, my dear, ne? But this friction, yes, no, I'm going to come to components. So let me explain the friction. Friction, we have the static friction, and we have the FK, which is the kinetic friction. This one is for moving object. This one is for stationary objects. That's the difference. Ne? Let me draw a demonstration to emphasize the two. Oh. If maybe I have this object and I'm trying to push it with this force, this is the force applied, ne? And this force is not moving. Yes, FK, it's still FF. Yes, it's the same thing. It's the same thing. So if I'm pushing this and it's not moving, this guy, it means sort of the friction that you are going to draw, the friction that you are going to draw, the friction that you are going to draw here, what kind of a friction are we going to have here if this object is not moving? Can I get an answer? What kind of a friction are we going to have here if this object is not moving? Yes, it's going to be a static friction. It's going to be Fs, right? Stop friction. Yeah, you can take it like that, it's still fine, my friend. So let's continue. Now, obviously, whenever you have your F applied, obviously you'll have your force of gravity and you'll have your normal. Yeah. Then it's child. So this is the difference between the force diagram and the free body diagram. Ne? So any questions? I'm closing the session at 1:30. Any questions? Ask. I need people to ask questions, Pep. This is the difference. So the closed diagram. Thank you very much for the rose. Thank you very much, Nate. Thank you very much, my friend. I hope God blesses you to pass, my friend. So let's continue and draw and see what it's the closed diagram looks like. If maybe we have okay, let me draw something like and I have this to be 5 kg. And I want to draw the close diagram for this. And I want to draw the closed diagram for this guy. So you see, okay, do we have normal here? Hey, I want to see people more. Do we have normal? Do we have normal more? Do we have normal? Thank you very much. We don't have normal. Why don't we have normal? Why there's no normal here in this case? Why are we having no normal? Yes. Yes. Because yes, it's hanging. The object is hanging. Not necessarily not moving, Mr. Wandili. It is hanging. It's not on top of the surface. That's another reason. The object is not on top of the surface. The object is not on top of the surface. Do you see this one? Do you see this one? This one is working on top of the surface. So in order for us to have normal, it has to be on top of, okay. But I can't draw it to be the exact, but it's fine. So this, it's on top of the surface. So it's working on top of the surface. This system is on top of the surface. But this one, it's not on top of the surface. So I can draw a free body diagram. Like guys, we can draw a free body diagram for this point and the free body diagram for this point. Yeah, fufa. So let me draw a closed triangle for this guy. And let me assume that this is 30 degrees. This is hanging. So now I'm going to draw this. This is going down relative to what? This guy is going down relative to what? This object is going down relative to what? It's going down relative to what? Gravitational force. Thank you very much. It's going down relative to its weight. So I'm not going to draw a closed triangle. That's the mistake that people they do. They are drawing the closed. They are trying to draw the closed triangle relative to the object. You can't draw a closed triangle relative to this object, but you can draw a closed triangle relative to this point, guys. Relative to this point. Because of why? That's where I have the high concentration of all the forces. That's where all the forces are highly concentrated. Because this force is not experiencing any whatever, funny, what. But this force is experiencing like the concentration of all the forces. So now I'm going to draw a closed triangle relative to this point here. I'm taking this point and I'm going to draw a closed triangle. So let me call this T1 and let me call this T2. Wabo? And let me, obviously this is going to be T3, but I'm just going to leave it like that because this force, it is relative to Fg. So I'm going to take this point and I'm going to see, okay, I'm having the force of gravity which goes down, right? I'm going to have, okay, I'm going to have the force of gravity which is going to be my Fg. Ne? Do you see it? And now I want you to answer me very carefully. I'm going to have this force. By looking at the diagram, what is this force? By looking at the diagram, what is going to be this force? Tell me, by looking at the diagram, what is it going to be this force? Come on, guys. Come on. No, I know, I know. But which tension? Which tension? Which tension? Which tension? Because I see two tensions there. Yes, it's going to be T2. Thank you. This one is going to be T2. Then what is going to be this force? What is going to be this force? What is going to be this force? This force is going to be, yes, it's going to be T1. Because this Fg, T2, T1. And what is going to be this degree? How much is it going to be this degree? How much is it going to be this degree? Yes, it's going to be 30 degrees. So this is the closed triangle. Yes. Yeah. I know. Thank you very much. Thank you very much. If you're on that spot, I appreciate, guys. I appreciate you taking your life very seriously. And guys, please subscribe, guys. Please subscribe. Here's my YouTube handle there. Please subscribe. I will post the recap. I will post the recap of this life on the on YouTube. Please subscribe. Can I at least get 10 of you guys to support my channel, guys. Just 10. Just for you guys to support my channel as I'm supporting you. And guys, if you know that you need help, please DM me and I will give you my WhatsApp number and I will add you on my waiting list if maybe. Thank you very much. Thank you very much, Skamosh. For private sessions, I just charge 200 per month, but it doesn't matter. If you know or you don't have that 200, follow, like, and subscribe. You'll always get my support. Whether you have the money, whether you don't have it, you will always get my support. Because obviously, if you are bringing that 200, it means you'll get more of my attention. You'll get closer to me. But if you are interested and you don't have money, I will just put you on the waiting list. Yes, thank you very much. God bless you too, Skamosh 44. Thanks for those words, my friend. Compliments are to be appreciated in this group. Thank you very much, Lyrel, one delay. Please go and subscribe, guys. And make sure that you subscribe to. After this session, I'm going to make sure that I edit this live and edit, and I post. Edit and post, and make sure that the most important parts you need to do, you need it on this live are there. But I would appreciate if you subscribe and you continue to push, take your life very seriously. If you need more of my attention, I don't charge much. I just charge 200 per month. And Tlala. Rena re makhoi she, rena re makhoi. A re tshware ke tlala. A re prioritize dijo, ra fasta. Wa bona le skin sa ga se bjang? Asna mafura. Skin sa ga asna mafura. Re banna ba fasta, re banna ba phela ka thapelo, re banna ba fasta. But please guys, yes, it's a pleasure, Larael. It's a pleasure, my friend, and I hope, thanks for taking your life serious. Thanks for, and please go and subscribe, Larael, man. Please, man, just go there. Tagalani Donald, at Tagalani Donald. Go to my bio. There's my YouTube link, and you go there. Subscribe. Chaili. Thank you, Mr. Lyrel. Thank you very much, guys, for your time, and I hope you get the best of this year. And unfortunately, thank you, Asi Pilele. Thank you for your support. Thank you for your support, guys. Doesn't mean no revele if you can't afford those private sessions, I won't support you. I will support you. I'm not here for money. I'm not here for people's pockets. I'm here to help you. That's why I can spend these hours for you to be what? No, is act or is come on. Like the profile pic is the same as that one. I wanna that guy there. That guy there. There. The profile pic is the same, guys. Ne? Yes. YouTube. The link, ne? Ish. Or a moderator, you can go to YouTube quick and and make sure that you post the link. My mistake is not to post the link on my bio, ne? I have to post the link on my bio. But if you are looking for it, you can DM me. I will send you the link. You can DM me. I will send you the link. Your support would be appreciated, guys. And I also do maths. I've been focusing on maths for a very long time, and people they've been telling me, alright, guy, do physics nyana, what. Anhlalwayo. But it's fine. Please DM me, I will send you the link. Yes. Yeah, you can search Mr. TK. Yeah, you can search Mr. TK. Oh, if maybe that one doesn't work, you can search Mr. TK. The profile pic is that one. I didn't change anything. You will see it. The profile pic is the same. Oh, yeah. Let me not waste any more of the time, guys. See you today at 12 o'clock. We are continuing. 12 o'clock, we are continuing. Free body diagrams, force diagrams, yara, complaining all night about schoolwork. Thank you very much, my friends. Have a lovely day and God bless you. Make sure that you pray. Don't forget to pray. Put God first. Don't prioritize friends. Unfortunate. It's unfortunate for them. Yes, thank you. Skamoshed. Yeah. One delay. Yeah. Don't worry. Cause you see, like now, I'm a bit disorganized, I'm a bit disorganized, but I promise you, everything will be covered, even chemistry. I'm tired of people, what, organic molecules, isomers, wara, boiling point, melting point, dipole, alcohol, or what's. Yo, yabo. Oh, thank you very much.